So in this example, we want to use integration to find the area between two functions. The first one is y equals negative 0.2x plus 1, and the second function is y equals 0.1x minus 2. So in order to find the area between these two functions, we need to know which one is the greater function, the one that's on top, and which one is the smaller function, the one on the bottom. Now, in this case, it's relatively easy to see that the blue line with the negative slope is the function on top. And so we see here that this is the function that has the negative slope. So this is the upper function, so to speak. And so this one has to be the lower function. We also notice that the limits of integration are given to us. We're starting at 0 and we're going over to 7. So we're only going to this line right here on the graph. And so the area is not going to completely fill up this triangular tip over here on the right side. It's just going to be this figure here that's shaded in. So knowing that information, let's go ahead and build the integral that we're going to use. The limits of integration start at 0 and go up to 7. And to find the area between two curves, we integrate the upper function minus the lower function. And we said the upper function is the one with the negative slope, so that goes first. The order is important there. Notice that there's a negative sign here that we can distribute into both of these terms. And so I'm going to do that to make the integration a little bit easier down the road. So this negative times 0.1x gives me this term. And then this negative times this negative gives me a positive 2. If I combine like terms, negative 0.2x and negative 0.1x are going to give me negative 0.3x, and then positive 1 here, and then positive 2 over here is going to give me 3. So this is just a little bit easier to integrate than the original function up here. So a little bit of simplification can go a long way. Now we need to find the antiderivative of this expression. Recall from the power rule for antiderivatives, the power here for the x is a 1, so we're going to increase the power by 2, divide by that same new power, and keep the negative 0.3 coefficient. That's the antiderivative of this first term. The antiderivative of the second term is 3x. Remember, you can check that because going in the opposite direction, starting down here, you can take the derivative of this, the derivative of 3x is 3, so we know that's correct. Now, to evaluate this, of course, this vertical line means we're going to evaluate this antiderivative expression at these 2 points. And the fundamental theorem of calculus tells us to subtract the differences, or subtract the values that we get when we plug in these two limits of integration. So we plug in 7 first, the upper limit goes in first, so that's what I'm doing here in this left set of parentheses. And then we subtract, via the fundamental theorem of calculus, what we get when we plug the lower limit of integration into the antiderivative expression up here. So we put a bunch of zeros in, which it turns out this whole thing ends up going to 0. When we do the calculations, we get 13.65. So what that tells us then is that the area of this blue shaded region, the area between these two curves from 0 to 7, is 13.65 square units.